Hi class, today we're going to talk about Venn diagrams. So we're going to build on some of the things we learned with categorical logic, the categories of all, no, some are not. We're going to diagram arguments, and then we can use those diagrams to see whether or not they're in the right logical format. So it's a nice shorthand way of looking at things and seeing if something holds to be true or not based on the categories that have been created. So I'm going to share my screen and we'll look at some examples that I think will help. So here's an argument, right? Premise 1, all sensitive persons are dreamers. Premise 2, all dreamers are poets. Premise 3, all sensitive persons are poets. Is it in the right logical format? If the premises are true, does the conclusion have to be true with necessity? Again, this is a deductive argument. You can see that these are all A statements. You know, all SRP, right? So they've broken it down for you on the right here, right? All sensitive persons are dreamers. All dreamers are poets. All sensitive persons are poets. So you sort of have what they call a subject, S, a predicate, P, and a middle term, M. The way to diagram it is you want the subject and the predicate of the conclusion up top. So you have sensitive persons and poets, right? Up top, S and P. And then the M term, the middle term, is the third term, and it goes on the bottom. So we have sensitive persons, we have dreamers, and we have poets. The conclusion has sensitive persons and poets. That goes on top, these two. Dreamers is the middle term. It goes on the bottom, and you set up your 3 circles that way. Once you have your 3 circles, now you diagram. Here's the key. You only diagram the premises. You do not diagram the conclusion. You only diagram the premises. After you diagram the premises, you look and you say, does the conclusion follow by necessity given my diagram? So you don't diagram the conclusion, you look to see if the conclusion is shown in the diagram of your 2 premises, right? So I'll show you what that means. So you've got the premise, you got the subject and the predicate of the conclusion, you got the middle term, and then you diagram premise 1. All sensitive persons are dreamers. So you you black all this out down here. Because if you are a sensitive person, you must also be a dreamer. So all sensitive persons exist here in the overlap with dreamer. Okay, that's an A term. The next premise, all dreamers are poets. Okay, we're going to diagram that. So if you scroll down, so you keep your diagram here, right? All sensitive persons are dreamers. Then you do all dreamers are poets. So all this needs to be blocked out. Okay, you're scratching this off. You're pushing all dreamers into this category, right? That's also an overlap with poets. All dreamers are poets. Now we have this diagram. Our 2 premises are already diagrammed. And we ask, can I see the conclusion in this diagram, right? And the conclusion is all sensitive persons are poets. So I come down. Sensitive persons all exist in this realm. They've been pushed here. Nothing can exist in the shaded areas. So all sensitive persons exist here, and this area is in fact encompassed by poets, right? So all sensitive persons are poets. That follows. I diagram the first 2 premises. I look, the conclusion holds based on what we drew. This is a valid categorical argument. All sensitive persons are poets does follow by necessity from these 2 premises, and we can see it in the diagram. All sensitive persons exist here. That's encompassed by the term poets. We're good to go. A word of note. This does not mean all poets are sensitive persons, right? There are poets that exist out here outside the realm of sensitive persons. However, all sensitive persons are in fact poets. It's the same thing if I said all Pepsi products are sodas, not all sodas are Pepsi products, right? That makes sense. If you're a Pepsi, you must be a soda. If you're a soda, you don't necessarily have to be a Pepsi. If you're a sensitive person in this diagram, you have to be a poet. If you're a poet, you don't necessarily have to be a sensitive person. And that's why we can make category mistakes that we want to avoid, right? By doing Venn diagrams. Okay, the next example. No unicorns are black things. Some black things are dogs. Therefore, no unicorns are dogs. Again, we have no SRM, an E statement, some MRP, right? An I statement. No SRP and E statement. No unicorns or dogs. You want to make sure that the subject and the predicate are up here, right? So you have unicorns as the subject, predicate dogs. So S, unicorns, P, dogs. And then the M term is the third term left out. So unicorns and dogs are these two. Black things are M down here. So we know what we're doing. Then we just diagram. No unicorns or black things. S is unicorn, M is black things. We have to black this out, right? Black it out, black it out. Nothing can exist in the overlap, right? Because if you're a black thing, you're not a unicorn. And if you're a unicorn, you're not a black thing. Premise 2, some black things are dogs. The X must go here, right? That it's both a black thing and it's in the area that is overlapped with dog. If there was an X here, you're talking about some dogs are not black things, right? But the idea is some black things are, so you want it to go in the overlap between the two. We've got it diagrammed. The next claim is no unicorns are dogs. So this is the category unicorn. This is the category dog. Unicorns can exist here, right? Unicorns can exist in this area. And this is an overlap with dog. These things here are both unicorns and dogs in this area. So the conclusion does not follow by necessity, because there are unicorns here that are also dogs, according to the diagram, right? So because there's something here, or there could be something here at least, this does not follow by necessity. So this is an invalid categorical argument, because we diagrammed the two premises and we looked, and lo and behold, the conclusion doesn't necessarily follow by what we diagrammed in the premises. Another example. No intelligent persons are gluttons. Some famous persons are gluttons. Some famous persons are not intelligent. So again, we take the conclusion, famous persons and intelligent. Famous persons, intelligent, right? The last things are gluttons, that's the M. No intelligent persons are gluttons. So you've got intelligent persons, P. You've got gluttons, M. You got to cross this out. There's nothing that is both a glutton and an intelligent person, right? So nothing can exist in the overlap. That's an E. Some famous persons are gluttons. S is famous persons, M is gluttons. The X must go here. There's some X in between the two, right? In between, like in the overlap between famous persons and gluttons. Now we've diagrammed the two premises. Now we just look to see if the conclusion follows by necessity. Some famous persons are not intelligent. So we know there's an X here, some famous persons, right? And we know it's outside of the category of intelligence. So there's some X that is both a famous person and not intelligent. So by necessity, we know that this is true, that the conclusion holds by necessity given what's below. And because of that, this is a valid categorical argument, right? Sometimes there are some statements, like I and O statements, and we're not sure where to put the X, and so you have to draw a line connecting, right? So here you have some animals are furry, some furry things are cats, some animals are cats, right? All some claims, all I claims. When I say some animals are furry, right, that is between P and M. So this is cats, excuse me. Yes, this is animals, S is animals, P is cats, M is furry, right? So some animals are furry. S is animals, M is furry. So the overlap is the X is either going to go here or the X is going to go here, right? So it's these two X's, because it's got to be somewhere in the overlap between S and M, between animals and furry. But we're not sure where it goes, right? So you put an X both places and you draw a line. Deductively, you can conclude nothing from that because we're not sure where the X is. The X could be in either location or maybe it's in both. We don't know. And since you don't know by necessity, deductively, that's not helpful. The next thing is some furry things are cats. So here, P is cats, M is furry things. We know it's got to be either here or over here. We're not sure where. We put an X both places. We draw a dotted line between them. And since we look at this diagram and we're not sure where these X's go with certainty, it's an invalid deductive argument. Anytime you have an X in two places with a line because you're not sure where it goes, If it ends that way, it's an invalid deductive argument. Okay. All right. So we'll do a couple more examples and then I'll stop. Number one, all animals feel pain. All things that feel pain are able to think. Conclusion, therefore, all animals are able to think. So if you look at it here, the conclusion, all animals are able to think. You say animals is S, able to think is P, okay? The subject and predicate of the conclusion. Things that feel pain is the M term down here. So you've got your three circles, and then one at a time we diagram them. All animals feel pain, okay? If you're an animal, you got to cross this out, right? You got to cross this out. Push all animals into, excuse me. There's animals and feel pain. So you cross this out, right? You cross this out. You push all animals here. All animals are going to be here in one of these two places. Because if you're an animal, you must feel pain. All animals feel pain. That's the A claim. The next claim is all things that feel pain are able to think. So we've got feel pain, able to think. So I've got to cross this whole thing out, right? We've got to cross this out. If you feel pain, you must be able to think. So everything that feels pain goes into this area. And then we look at the conclusion, and it says all animals are able to think. Now, does that show all animals exist here? Because that's the only place they can exist. Everything else was crossed out. So all animals exist here, and that is in the overlap with the able to think. So all animals are able to think does follow. When we diagram those first two premises, we can see that it's true. We say this is a valid deductive argument, right? All right. Number three, no good persons are cruel to animals. Some children are cruel to animals, therefore some children are not good persons. So we get children, good persons, cruel to animals. Okay, we've got all three categories lined up, and then we diagram one at a time. No good persons are cruel to animals. So this is cruel to animals, this is good persons. You've got to say there's nothing in the overlap. If you're cruel to animals, you're not a good person. If you're a good person, you're not cruel to animals. Nothing can exist here in the overlap. Okay, E statement. Two, some children are cruel to animals. The only place for that to go is here, right? The overlap between children and cruelty to animals. It can't go here, that's blacked out. So it has to go here. And then we look at the conclusion and it says, therefore some children are not good persons. Does that follow from the diagram? There's an X here, so there's some child that exists here, and this child that exists here is outside the category of good persons. So some children are not good persons follows deductively from the argument. This is valid. So this is how Venn diagrams work, and it helps us determine valid versus invalid. I'm going to do one more, and then we'll stop. Number 7, all diets require willpower. No things that require willpower are simple. Therefore, no diets are simple. Okay, so we get diets, simple, willpower, 3 categories. All diets require willpower. So if you're a diet, you must require willpower. So you cross this out. You can't be a diet over here. These are things that don't require willpower. So we cross all this out. All diets get pushed into one of these 2 areas. If you're a diet, you must require willpower. So you have to exist here. Premise 2. No things that require willpower are simple. So willpower and simple, there's an E claim. You've got to cross this out, right? So if you require willpower, you're not, this is the stuff that's willpower. It must not be simple. If it's simple stuff, then it doesn't require willpower. Nothing exists in the overlap. Then we look at the conclusion. Therefore, no diets are simple. Can we see that? Right? All diets exist here because you can't exist anywhere it's been darkened. All diets exist here. This is outside the category of simple. So there are no diets that are simple. That is absolutely true by necessity. We say it's valid, and we're good to go with the deductive argument. So I hope this is really helpful to you. I hope diagrams are making sense. Again, the whole point is find simple techniques to diagram, watch for validity, help us make good arguments to get closer to truth. create better worldviews, avoid fallacy. Please let me know if you have questions, and I'll see you guys online.